Point 1 is about quadratic functions. This should feel familiar to you. So we're going to kind of review. We've done a little bit with quadratic equations earlier this year. So now we're talking more about the graphing part of it. So just as a reminder of the different parts that we have here, we've got, here's my parabola. The x-intercepts, of course, where the parabola crosses the x-axis. The y-intercept, where the graph crosses the y-axis. We have the vertex, which in this case is our lowest point. So that's where we're going to find our minimum value. But remember, sometimes the parabola can open down, and then we would have a maximum and not have a minimum. Then we have an axis of symmetry that actually passes through the vertex. So it is going to be, it's a vertical line, so it's going to be x equals a constant, and that constant will be whatever the vertex is. So we have two different forms of our quadratic function. We have the general form and we have standard form, or also called vertex form. Now I think last year in Algebra 2, our Algebra 2 textbook referred to this one as standard form. There is a little bit of discrepancy by different authors. Sometimes they'll call this just graphing form or vertex form, but your textbook, and there are other textbooks that do this as well, call this general form, this standard form. So one of the things I want to talk about is, there are certain features that are a little easier to figure out based on the form of the graph. For example, if you want to know the y-intercept, well, to find the y-intercept, we let x equal 0. It's really easy to find the y-intercept if you have it in general form, because the y-intercept is just going to be this value of c. If you let x equal 0, you're going to get this. So that's really easy to find. Over here, it's going to require a little bit of extra work. So it's not just k. That's not the y-intercept. However, if you want to know the vertex is very easy to find if it's in standard form, which is sometimes why it's called vertex form, and the value of the vertex is just the coordinates hk. So again, it's just depending on the format you have it in, it's going to tell you different things. If you wanted to find the x-intercepts, then you're going to set the function equals to 0. Over here, with this format, you would either be factoring it, using the quadratic formula. If you do it with this format, then you would be using the square root property. Remember, we have that chart, 5 ways to solve quadratic equations, and depending on the format is how we would choose to solve it. I want to talk about how these are related. Something that's important in how they're related is this value of a. Notice that you've got a in both parts. Remember that this value tells the vertical stretch or compression. As well as the direction of opening. So if it opens up, the value of a is going to be positive. If it opens down, the value of a will be negative. If this value of a, if the absolute value of a is greater than 1, it's vertically stretched. If the absolute value of a is less than, or is in between 0 and 1, then it would be a compression. So I guess that's not part of the sentence, and that's a less than 1. So to define those. So it is the same value of a. So then how does the vertex hk relate to a, b, and c? And that's one of the things I want to show you that I found interesting. So since these are both defining the same parabola, they have to be equal. So I know that ax² plus bx plus c has to equal a times x minus h quantity squared plus k. So I'm going to leave the left side alone, but on the right side, I'm going to multiply this out. I'm using the shortcut, so we square the first term, multiply and double, square the last term, and then I'm going to distribute. So this is going to be 2axh plus 2ah squared plus k. Let me recopy this. Actually, I'm going to switch one thing real quick. What I switched was how I wrote this out. I had 2axh, I changed it to 2ahx, which of course doesn't matter since multiplication is commutative. Here's the reason why I did that. We can match these up. So I've got the ax squared right here. I have those on the same side. So those are equivalent. Notice that this is the only term with an x in it. So I've got this negative 2ah, and that's going to have to be equal to b in order for these two pieces to match up. So b has to be equal to negative 2ah. Now notice from here, if I wanted to solve for h, which is my x-coordinate on my vertex, I could divide by that negative 2a, or I can put the negative at the top and say h. Well, let me rewrite this. So we could have h equals the opposite of b over 2a. That looks familiar. And we talked about that in Algebra 2, but I never showed you why it's true. The other thing I think is interesting is this whole, let me change colors again. This whole piece right here does not have a variable in it, does not have an x in it. So that is c. So c is this 2ah squared plus k. So if you wanted to know the y-coordinate of the vertex, you could actually just take c minus 2ah squared. Or if you didn't want it in terms of, if you didn't want the h in there, sorry, kind of making a mess of this, then you can actually replace the h squared with this squared and have it just in terms of, let me do that, let me show you. So we could take this, instead of an h squared, I'm going to take this negative b over 2a quantity squared. And you could simplify that. I'm not going to do that. But you could simplify it, and then you would have the y-coordinate of the vertex in terms of a, b, and c. Now, I don't know how helpful this part will be. This part, however, will be extremely helpful. And we used that a lot last year. And we'll still use that. So for this first example, write f of x equals 2x squared minus 4x plus 5 in standard form and give the vertex. Remember, standard form is we're looking for this. This is in general form. We want to change it to this. So I need to know the vertex. I already know a. This is the value of a right here. A is 2. I already know that. So I know that's going to go in that spot. I need to know the h and k. So I'm going to make use of what we just talked about, the opposite of b over 2a, which in this case, b is negative 4. So the opposite of b is positive 4 over 2 times a, or 2 times 2. So I get 1. So I know my value for h. Now I need to know the value for k, so I have to evaluate f of 1. So we get 2 minus 4 plus 5. So we get 3. So my value, my vertex, I now know is 1, 3. So now I know that f of x equals 2, because that's the value of a, x minus 1 quantity squared plus 3. Now you can check these if you graph this on your calculator and then maybe change the graphing if you don't have a colored calculator, the colored graphing, but you could change it to a solid line, a thicker line, and graph this, and you'll see it trace over itself, and then you'll know you did it right. Did we answer all the question? Give the vertex. We did. Okay, example 2, determine whether there is a minimum or maximum value. Find the value and the axis of symmetry. So right away I know that this parabola opens down. So I know that there's going to be a maximum, but no min. So I know there's going to be a maximum value, and now I've determined that. I should say there is a maximum value. And now I need to find what it is. Well, the maximum value is going to be the y-coordinate of the vertex. That's what the maximum value of the function is. That's the highest point. So I'm going to have to find the y-coordinate of the vertex. But before I can do that, I have to find the x-coordinate. So to find that h value, the x-coordinate of the vertex, I'm going to do the opposite of b over 2a. So we get, it's going to be a positive 6/8 or a positive 3/4. And then I need to evaluate h of 3/4. I did it on my calculator. I got 1.25, which is the same as 5/4. So I would expect that you would plug that in. I mean, you could do it by hand if you had to, but you know, calculators are a tool. So now we know that's what we were after. So the maximum, find the value. So the max value is 5/4, and the axis is symmetry. And that's, we already know that because it's the x-coordinate of the vertex. So the axis is symmetry. And make sure you report that as a vertical line is x equals 3/4. So when you, in many cases, when you're talking about a maximum value or a minimum value, we will have context to the problem. And then I would say something like 5/4 feet or whatever the context of the problem was. So just be aware of that. Example 3, determine the domain and range of this function. Now you should know, hopefully, that from your experience that for parabolas, that the domain is just all real numbers. So we have from -infinity to infinity. That's our domain. Now I know this parabola opens up. So my range is going to depend on whatever this minimum value of my function is. So I have to find the y value of the vertex, and that's going to be my lowest point. So I have to find the opposite of b. So to find the h value, the opposite of b over 2 times a. So I get 1. So g of 1 so I have 2 minus 4 plus 2, so I get 0. So my range is, it's going to be greater than, y is greater than or equal to 0, so it looks like this. Okay? Find the general form of the quadratic equation with vertex -5, 3 that passes through the point 2, 9. Well, the general form is the ax²+bx+c, but I don't start with that one. I'm going to start because I'm given the vertex. So I know that this is h and this is k. So I'm going to think about f of x equals a, x minus h quantity squared plus k. So what do I know already? Well, I know that this is going to be x minus a -5, so that makes that plus 5, quantity squared, plus k is 3, so I fill that in. So what don't I know? Well, I don't know a, but I need something to plug in here for x and for f of x. Well, they give me a value, so this is a value for x, and this is a value for f of x. Remember, f of x is like having a y. So I'm going to substitute those in. 9 equals a, 2 plus 5, quantity squared, plus 3, and now you can solve for a. So here we're going to have 7 squared is 49, so I have 49 times a plus 3. So when I solve this, and it's not necessarily a nice number, we get 6 over 49. So now my equation for f of x is 6/49 x plus 5 quantity squared plus 3, which if that's all I needed would be great, but they asked me for general form. So I'm going to have to multiply this out. So this is going to be x squared plus 10x, because you multiply and double, plus 25. And then unfortunately, I am going to have to distribute that. So I'm going to have 6 over 49 x squared plus, well, this is easy, 10 times 6 is 60 over 49x. Okay, I'm not going to lie, I don't, well, yeah, we can do this. 150 over 49 plus 3. I know you guys would have grabbed a calculator by now. Hopefully I haven't made a mistake. Okay, I'm grabbing a calculator now. So make a little computation. I get 297 over 49. Okay, well, that's in general form. And that, I don't think the homework problem I assigned is that hard, but if it is, you'll be ready for it. So in the next problem, sketch the graph of f of x equals x squared minus 7x plus 3. Give the vertex, the axis of symmetry, and the intercepts. So need to find the vertex, so I may as well do that right away. I'm going to use that to graph it anyway. So we're going to take the opposite of b over 2a. So that's my h value. So I get 7 halves, or 3.5. And then we have to find, we're going to plug that in to find the y value. Okay, so I did that and I got negative 37/4, which is negative 9.25, which would be helpful for graphing. So why can't I grab that? Okay, I just moved my axes around to make it a little more convenient. So I'm going to plot the vertex. So we had 3.5 and about 9.25. So I've got my vertex. Now I have to have my intercepts anyway. So, or actually what I'll do, because this is it has the a value of 1, so it's going to be like the parent graph. So if I go over 1, I'm going to go up 1, which is one reason why I wanted to scale by ones. If I go over 2, I'm going to go up 4. And if I go over 3, I'm going to go up 9. I'm going to go ahead and do that because I want to get up here to the x-intercepts. I just want to be able to draw this a little better. So I'm sketching the graph. Doesn't have to be perfect. Okay, so there's my sketch. My axis of symmetry is going to go right here. So that is x equals 7 halves. My vertex value, since we're being asked to do that, is 7 halves, negative 37/4. You can do decimals if you want. And now we have to get the intercepts. The y-intercept is easy. We plug in a 0, f of 0, and we get 3. Okay, so the point 0.03 is the y-intercept. The x-intercepts, a little harder. We let f of x equal 0, so we are solving this. It is not factorable, so I'm going to use the quadratic formula. So x equals opposite b plus or minus square root b squared minus 4ac. You're singing it, aren't you? All over 2a. So we get 7 plus or minus the square root of, we've got 49 minus 12 is 37 over 2. And 37 Square root of 37 can't be simplified, so you can leave your answer. Remember, this is two answers, 7 plus the square root of 37 over 2 and 7 minus the square root of 37 over 2. If you wanted to know the decimal approximations, you could actually plug it into your calculator because you see that our graph does cross twice. And this last example, write the equation for the graphed function. So what we're going to pick out of here is the fact that I know what the vertex is. So the vertex is 3, -4. And then I'm also going to use my graph to see if I can tell what the movement is, like over 1, up. Does it go over 1, up 1? Well, if I go over 1, notice it's 2 boxes is the scale. So over 1 doesn't go up 1, it goes up 2. So if I go over 1, I go up 2. Well, what happens if I go over 2? If I go over 2, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So I can tell this is vertically stretched by 2. So my value of A is 2. That's all I need. So I'll call this f of x. We're going to have 2 x minus 3 quantity squared minus 4. And that's the equation for my graphed function.